That is the first example problem. Let A be the set of all 50 students of class 10. So A is the set of all 50 students. Say S1, S2, S3 up to what? S50. So there are 50 students. S1 stands for student 1. S stands for student. Here S50 stands for 50th student. So A be the set of all 50 students of class 10 in a school. That is the set A. Let F is a mapping from A to N. What is that N? Set of all natural numbers. So natural numbers means starting from 1, that is counting numbers. 1, 2, 3, 4, so on. Okay. So where the function f of x is nothing but the function f of x is nothing but what? Roll number of the student. Roll number of the student. The function is defined as follows. F of x is equal to the roll number of the student. So what is the question? Show that f is 1, 1 but not onto. Okay. So what is the definition of 1, 1? To be 1, 1, if we have a distinct elements, it means we must have distinct images. If we have the same images whose corresponding elements are also same. What about onto? What is the definition for onto? For every element of codomain, there exists a corresponding pre-image in the domain. For every element of codomain. Okay. So here x belongs to A. You know that x belongs to A, f of x belongs to the codomain. X, f of x means image of x. So if we have x here, it becomes f of x here. Okay. So this is an elements of first set, that is A, that is x belongs to A. F of x is the set of all elements of the codomain, second set, that is natural. Therefore f of x belongs to natural number. Is it okay? So here x belongs to A means what? Here x is a belongs to A. Student of A means what? A is the set of all students. So x is a student in a school. Okay. Among 50 students, x is one of the student. So which is equal to roll number of the student. So n, here n is a natural number. Roll number of the student means what? If we have 50 students here, that is, I am taking narrow diagram to better understand. Here A and N. Here A, for A, what is A? Yes, 1, student 1, student 2, student 3, up to student 50. What is natural numbers? 1, 2, 3, so on, say 10, so on, say 50, and so on, say 100, so on, say 1000, crore. Okay, that is the natural number, starting from 1 up to infinity. So that is natural number. Here, the definition is, it says f of x is equal to the roll number of the student means, here S1 is maps to 1, that is f of S1. The student, the number student 1, which he or she has the roll number, say 1. Okay. S2 maps to 2. It means f of S2 is 2. It means f of S2 is the student 2 have the roll number, namely 2. If I take S3 maps to say 50, it means what? The student 3 have the roll number, say 50. Is it okay? So to understand clearly, I am taking S3 maps to 3. What about S50, which maps to 50? Is it clear? So all the students have the roll numbers. So if we have two different students, then their roll number also different. Is it okay? So that is x1 is not equal to x2. That is a student, x1 and x2 belongs to what? A. If we have different students, then whose roll number? F of x1 stands for what? Roll number of the student x1. So f of x2 stands for roll number of the student x2, which also not equal, because no two different students have the same roll number. Is it clear? So therefore x1 not equal to x2 implies f of x1 not equal to f of x2. So f is 1, 1. Okay. So this is 1, 1. It is clearly 1, 1. Why it is 1, 1? Because no two different students have same roll number. That's why it is 1 1. Okay. What about onto? Why it is not onto? Reason is, if I take 51 to say 100, 51, is it 51 has a pre-image? To have a pre-image here, there must be a student, say 51th student, but what is the set? Set A with a set of all 50 students only, not 51 students, not 100 students. Okay. So therefore, the 51 do not have a corresponding pre-image. If I take 52, 52 is a natural number, but that number do not have a pre-image in the domain. If I take 100, 100 is a natural number, that is an element of a codomain, but do not have a pre-image in the domain. Therefore, there are more elements which do not have pre-images in the domain, therefore which is clearly not onto. Is it clear? Next example problem. Show that the function f from n to n, that is set of all natural numbers to set of all natural numbers itself, given by f of x is equal to 2x, is 1 1 but not onto. We have to show this given function is 1 1 but not onto. Is it okay? So let us consider the equation first. So what they given? The function f is a mapping from set of all natural numbers to natural numbers given by f of x is equal to 2x. Means if I take 1, 2 1s are 2. If I take 2, 2 2s are 4. That is 2 maps to 4. If I take 3, 3 maps to 6. Is it okay? So that is the function. Here, first 1 1. So to be 1 1, what is the definition? Recall. The definition is what? If f of x1 is equal to f of x2, it implies x1 must be equal to x2. Or if x1 not equal to x2, we must obtain f of x1 not equal to f of x2. So let's apply the first definition, that is, if f of x1 is equal to f of x2 means this is the hypothesis, that is information. This is the information part. We must use this part. We must show x1 is equal to x2. Is it clear? So we use this part. We must show the corresponding elements. x1 is equal to x2. If I take f of x is equal to f of y, you must show, if I take this condition, you must show x is equal to y. Is it clear? So this is the corresponding elements x and y. Here we have x1 and x2. Is it okay? So for that, consider the information part. What is the information part? F of x1 is equal to f of x2. Let us take f of x1 is equal to f of x2. So what it means, f of x is 2x. What is f of x1? F of x1 becomes 2 into x1. That is 2x1 is equal to. So f of x is 2x. If I take f of x2, replace in place of x by x2, f of x2 is 2x2. This is 2x2. So f of x1 is 2x1, f of x2 is 2x2. Here 2 is not equal to 0. We can cancel 2. Okay. So therefore we get x1 is equal to x2. So we take the information part, we arrive at claiming part, that is f of x1 is equal to f of x2. This implies x1 is equal to x2. So therefore we conclude that f is 1 1 according to the definition. Is it okay? Next, check for ontoness. Here I am taking ontoness. So what is the definition? Recall. For all y belongs to the codomain. Here y is codomain. In this case y is what? Natural numbers. Codomain. There exists pre-image. X belongs to x, that is domain. For every element of codomain, there exists a corresponding pre-image in the domain. That is the definition of onto. Such that f of x is equal to y. Okay. Such that f of x is equal to y. So here, if I take any number is here f of x is equal to 2x. For take any natural numbers, say I am considering arrow diagram to better understand. here natural numbers, here natural numbers. Okay. So now I am taking say 1, 2, 3, 4, 5 so on. Is it okay? So here I am taking 1, 2, 3, 4, 5 and so on. Because natural numbers starting from 1, counting numbers. According to the definition, f of 1 maps to what? 2 ones are 2. 1 maps to 2. Next, if I take 2, 2 twos are 4. 2 twos are 2 maps to 4. If I take 3, 3 maps to, here is the 6. It maps to 6. What about 1? What about 3? What about 5? All odd numbers, all odd numbers, odd natural numbers, all odd natural numbers do not have pre-images. So therefore, the given function f not on 2. Why it is not on 2? To be on 2, for every element of codomain must have pre-image. So here 2, here 1 don't have pre-image, 3 don't have pre-image, 5 don't have pre-image. In fact, all odd natural numbers do not have a pre-image in the domain. So therefore, which is not on 2. Okay. So you can write like this also. If I take f of x is equal to say y. This is f of x is equal to y. What is the definition of f of x? Is 2x right here. 2x is equal to, okay, is it visible? 2x is equal to y. Now what about y is equal to 2x? Okay, what about x? The value of x is y by 2. Is it okay? So value of x is y by 2. It means if I take say y is equal to 1. If I take y is equal to 1. What should be x? Y by 2. That is 1 by 2. 1 by 2 means what? 0.5. Is it this 0.5 belongs to domain? What is the domain? Natural number. So does not belongs to domain. So we don't have such pair. So for every y belongs to y, there is x belongs to x. We don't have such f of x is equal to y. Therefore we conclude that which is not on 2. Is it okay? So this example problem. Prove that the function f is a mapping from set of all real numbers to set of all real number itself given by f of x is equal to 2x is 1, 1 and on 2. Prove that it is 1, 1 and on 2. That is both 1, 1 and on 2. So solution. So what is the function here? Function is a mapping from set of all real numbers to real number defined by f of x is equal to what? 2x. Real numbers means here real numbers means what? Natural numbers. It includes whole numbers, integers, and also it includes rationals, and also it includes irrationals. Okay. So that is rational means if I take 0.5 terminating, irrational means non-terminating. I am taking pi. Pi is 3.14 and e is 2.71 and so on. There are some numbers. Okay. So which is non-terminating. So this is terminating 0.5, 0.25. Okay. So these all are real numbers. Okay. So that is real numbers defined by f of x is equal to 2x. In the previous example, we have the same question, but in place of real number, we have natural numbers. But here in place of real numbers, in place of natural numbers, here we have the real numbers. Okay. So first start with 1, 1. So to be 1, 1, what is the definition of 1, 1? F of x1 is equal to f of x2. If we take f of x1 is equal to f of x2, it implies x1 must be equal to x2. Is it okay? So that is, definition is what? If f of x1 is equal to f of x2, you can take in place of x1, x2, x and y. Okay. We show that x1 is equal to x2. Okay. So consider what we have to consider. F of x1 is equal to f of x2. So what it means? F of x is 2x. F of x1 is 2x1. f of x2 is 2x2. Same reason, 2 is non-zero, 2 is non-zero, both are gets cancelled. Here x1 is equal to x2. So we show that x1 must be equal to x2. We get x1 is equal to x2. So thus, what we have to conclude? Thus, f of x1 is equal to f of x2 implies x1 is equal to x2. Therefore, f is 1, 1. Okay. Next, let us check for onto, whether the given function is onto. Prove that it is onto. Therefore, we must show which is onto. What is the definition? Definition is, for all y belongs to the codomain, for every element of codomain, there exists corresponding preimage. Say x in what? Domain. Such that f of x is equal to y. Such that f of x is equal to y. Here for all is important. For every element, take any element of codomain, there must be a preimage for that element in the domain. Okay. So that is an ontoness definition. So for this question, here I am taking f of x is equal to, so what's that? F of x is equal to y. F of x is equal to y, where x belongs to domain. And here y belongs to codomain. So what is the domain and codomain for this function? The first set is the domain, that is R itself. And the second set is codomain. Is it okay? So what is the definition of f of x? F of x is 2x, this is given, which is equal to y. So now, f of x is equal to 2x is equal to y, it means what? Y is equal to 2x. That's okay. What about x? X is equal to what? 2 into x is equal to y, means x is equal to y divided by 2. If we have 2 into x is equal to y, then x is equal to, here into 2 becomes divided by 2. If we have plus, then it becomes minus. If we have into, then it becomes divided by. Okay. So that is x is equal to y by 2. Here 2 into x, that is, therefore x is equal to y by 2. Clearly y by 2, take any real number whose fraction, that is divided by 2. If we divide that number by 2, clearly belongs to the what? Domain, because the domain is real number. If I take 1, what about x? X is 1 by 2. 1 by 2 is 0.5. 0.5 rational number, therefore it is clearly belongs to real number. 0.5 is a real number. Next, if I take y is equal to say 2, then what we get? X is equal to say 2 by 2. What is that value? 2 by 2 is 1. 1 is a natural number, therefore it is also a real number, because real number is a superset. Is it okay? So here I am taking, here, if I take y is equal to say 2, so what is x value? Y by 2. So x is equal to 2 by 2. 2 by 2 is 1. 1 is clearly belongs to real number. If I take y is equal to say 3, then what is x? X is equal to y by 2, that is 3 by 2. 3 by 2 is what? 2 ones are. If we have 1, that is 1.5. 3 by 2 means what? 1.5. 1.5 is clearly belongs to real number. Take any number. So, take any number in the codomain, there exists corresponding preimage in the domain. So, therefore, which is clearly onto. So, here the function is a mapping from real numbers to real number. That's why it becomes onto. If I have natural numbers to natural numbers in the previous example, which is not onto. Why? If I am taking 2, x is equal to 1 is clearly belongs to say natural number. That's okay. But if I take 3 is a natural numbers in the codomain. But 3 by 2 is 1.5. Is it 1.5 belongs to natural number? So which is not possible. So therefore, which is not onto. Is it clear? Next example problem. Show that f is a mapping from set of all natural numbers to natural numbers defined by f of 1 and f of 2 both are equal to 1. And f of x is equal to x minus 1 for every x greater than 2. What it means? F of 1 is 1, f of 2 is 1, and f of x is x minus 1 for x greater than 2. Greater than 2 means x is equal to 3, 4, 5, because here x belongs to natural numbers, therefore greater than 2 means 3, 4, 5, 6, 7 and so on. Okay. So for those, that is f of 3 is what? If I take 3, 3 minus 1, that is 2. If I take 4, then it becomes in place of x 4. 4 minus 1 is what? 3. If I take 5, then it becomes what? 5 minus 1. 5 minus 1 is 4. That is, f of 1 maps to 1, f of 2 maps to 1. That is, 1 maps to 1, 2 maps to 1. But 3 maps to 2. That is decrease in 1. If I take 4, 4 maps to 3. So that is the decrease in 1. 5 maps to 4. Is it okay? So that is 5 maps to its previous number, 4 maps to its previous number, say 3. So that is the function given. So we show that this is onto but not 1, 1. Okay. So let us start with 1, 1. 1, 1. To be 1, 1, what is the condition? If I take images are equal, then the corresponding elements are also equal. So if f of x1 is equal to f of x2, what we have to show? We show that x1 is equal to x2. Is it okay? So for that, I am taking f of 1 and f of 2. Here both are equal. Both are equal to 1. So here f of 1 is equal to f of 2. So image of 1 is equal to image of 2. Why? Because both are maps to 1. That is the element 1. So here f of 1, f of 2 both are equal because f of 1 is equal to f of 2 is equal to 1 by hypothesis, by the given part, that is information. Next, what about but? 1, is it equal to 2? Is 1 equal to 2? Never. So here but 1 not equal to 2. Images are equal, but corresponding elements. What is the corresponding element here? 1, here 2. If I have f of x1 is equal to f of x2, we must have x1 is equal to x2. That is, x1 is equal to x2. Then we say that it is 1, 1. But here f of 1 is equal to f of 2, but the corresponding elements 1 not equal to 2. So therefore, we conclude that f is not 1, 1. Is it okay? So next, this is over. Next for onto. So let us check for onto. So what is the definition? For all, take any element. For all y belongs to codomain, take any element. There exists a corresponding x belongs to the domain such that f of x is equal to y. So that is the definition of onto. Take any element of codomain, there exists a corresponding pre-image for that element in the domain. Okay. So that is onto. So for this, if I take an arrow diagram, so here the set, what is the first set? Natural numbers. Second set is also natural numbers. That is 1, 2, 3, 4, 5, 6. I am taking up to 6 and so on. 1, 2, 3, 4, 5, 6 and so on. Here. So what it means? F of 1 means f of 1, f of 2 both maps to 1. F of 1 maps to 1, f of 2 maps to 1. That is, 1 is, this is equal to f of 1 and also equal to f of 2. Next, what about 3? 3 maps to, here is the 3 maps to 2. 3 maps to 2. If I take 4, 4 maps to 3. If I take 5, 5 maps to 4. 6 maps to 5. 7 maps to 6. If I take 100, It maps to what? It maps to 99. Is it clear? 4 maps to 3. That is reduce in 1. 5 maps to previous one. 6 maps to previous one. 100 maps to previous one. That is 99. If I take 1000, what it maps to? It maps to 999. Is it okay? So that is, take any element of the codomain. So for all y belongs to codomain, take any element of codomain. So there exists a corresponding preimage. 1 has a preimage, 2 has a preimage, 3 has a preimage, 4 has a preimage, 5 has a preimage. So therefore, we conclude that for all elements of codomain, there exists a corresponding element, that is corresponding preimage in the domain such that f of x is equal to y. So here f of x is equal to y. If I take y is equal to, if I take 3, so if I take y is equal to 3, so what is f of x is equal to y says? F of x is equal to y says, f of x is what? X minus 1, which is equal to, say, y. Y is what? 3. Then what is x? 3 minus 1, taking right hand side, it becomes 4. So for 3, which has a preimage, namely 4. For 3, it has preimage, namely 4. Okay. If I take, say, y is equal to 5. If I take y is equal to 5, f of x is equal to y, here onto next condition. What is f of x? F of x is x minus 1, which is equal to, what is y? 5. So x is equal to what? 5 minus 1 becomes plus 1, that is 6. For 5, which maps to, which has a preimage, namely 6, that is 5 has a preimage, namely 6. 5 has a preimage, say 6. Take any element of codomain which exactly has a preimage in the domain. So therefore, it is clearly onto.